In 2024, a single robot in Dubai completed a 2-story building in just 24 hours. Only 2 human workers were on site. That same year, an AI-designed apartment complex broke ground in China, while in Austin, Texas, a development of 100 homes built entirely by 3D printing welcomed its first residents. This is not a story about some distant future. It is happening right now, on job sites around the world. The question is no longer whether this technology will arrive at your doorstep. The question is whether you and your practice will be ready when it does. Let's start with the numbers, because they tell the story clearly. The global construction 3D printing market was valued at approximately $1.8 billion in 2023. By 2030, it is projected to expand at a compound annual growth rate of 91%, potentially surpassing an estimated $75 billion. That is not steady growth. That is an explosion. And when you add the broader construction robotics sector, welding robots, bricklaying machines, drone surveying, and AI-driven project management, the global construction automation market is tracking toward roughly $300 billion by the end of the decade. No firm in the construction or design industry can afford to treat this as someone else's problem. So where does the technology actually stand today? 3 distinct approaches are currently in active use on real construction projects around the world. The first is concrete extrusion, large gantry robots or robotic arms that deposit layers of specialized concrete mix to build up walls and structural elements. This is the most commercially mature method available right now. Companies like Icon in the United States and Cybe Construction in the Netherlands are already selling homes built this way. The second approach is metal deposition welding, where robotic arms construct steel frameworks by laying down molten metal in precise paths, enabling highly complex, free-form geometries. The MX3D pedestrian bridge in Amsterdam stands as the global benchmark for what this method can achieve at scale. The third is biomaterial printing, using renewable inputs such as mycelium composites or reclaimed aggregates, which remains largely in the research and pilot phase, but is advancing faster than virtually any other construction technology right now. Crucially, each approach opens up an entirely different vocabulary of design possibilities for architects willing to engage with it. If robots are transforming construction, AI is fundamentally reshaping the design process itself. The key concept is generative design, where an architect inputs a set of structural, spatial, and performance constraints, and the AI generates hundreds or even thousands of design variations, then surfaces the optimal solution. Tools already embedded in professional workflows include Autodesk Format connected to Revit, structural optimization plugins like Millipede for Grasshopper, and emerging AI-native platforms such as SpaceMaker, now integrated into the Autodesk ecosystem. What makes the combination of AI and 3D printing genuinely disruptive is the closed loop it creates between design and fabrication. AI calculates structural load paths to minimize material use, generates a highly optimized geometry, and a 3D printing robot executes that geometry directly from the digital file. No translation, no manual redrawing. The result: internal lattice structures and organic curved wall surfaces that traditional construction methods could never produce at a competitive cost. Integrating AI with BIM workflows can reduce design error rates by as much as 72%. Automated BIM coordination has been shown to cut the time spent reviewing those errors by approximately 60%. And when that optimized design feeds directly into a 3D printing system, material consumption can drop by up to 40%. Now let's talk about practical action. What concrete steps can architects and interior designers take today to position themselves ahead of this shift? First, start integrating AI design assistants into your workflow immediately. Use image generation tools like Midjourney or Adobe Firefly for rapid concept exploration at the brief stage, and pair them with AI-powered optimization plugins available for Revit and Rhino to meaningfully increase efficiency in early-stage design. The combination of creative AI and precision optimization is already accessible to any practice willing to invest a few hours in learning. Second, build a 3D printing partnership now, even at a small scale. Companies like Icon, Apis Core, and a growing roster of regional specialists operate pilot collaboration programs for design firms. Start with interior components, custom furniture, facade panels, or decorative elements. Build your hands-on knowledge base before 3D printing becomes a standard client expectation. Third, elevate your BIM capabilities today. For modular and robot-assisted construction, BIM at level of development 350 or above is the accepted industry standard for factory-ready coordination. Robots read BIM files directly without precision BIM data. You simply cannot participate in this ecosystem. Integrating AI with BIM workflows can reduce design error rates by as much as 72%, which translates directly into fewer costly revisions and stronger client trust. Fourth, monitor the regulatory environment proactively. Building authorities across North America, Europe, and Asia-Pacific are actively updating smart construction frameworks and certification pathways. Those who understand the new rules before they are finalized will be the first to win permits and the clients who come with them. Let's be candid about where the industry stands. The United States and Europe currently lead in commercial deployment with verified residential projects, active homebuyers, and regulatory pathways already in motion. China is closing the gap at a remarkable pace, directing state-level investment into domestic 3D printing and robotics programs that have surprised many industry observers. Markets like South Korea, Singapore, and Australia, which combine strong engineering talent, significant labor cost pressure, and ambitious government modernization targets, are estimated to trail the global frontrunners by roughly 3 to 5 years in construction 3D printing maturity. But paradoxically, that gap is also an opportunity. The pioneers have already absorbed the early failures, the regulatory friction, and the expensive lessons. Those who follow, with rigorous preparation, can move faster. In South Korea specifically, major construction groups have already deployed AI-based concrete mixing optimization systems on active sites, and leading conglomerates are expanding dedicated construction robotics investments. But this is not a story exclusive to large enterprises. Smaller design studios and interior firms are already riding this wave through AI-assisted rendering, automated quantity takeoffs, and smart site management platforms. The barrier is not access to the technology. The barrier is the speed at which you choose to move. Every great technological transformation ultimately arrives at the same fundamental question: what will you choose to do when the ground shifts beneath your feet? Even as 3D printing robots take over routine construction execution, the work of imagining space, designing for human experience, and weaving together materials, light, and emotion will remain the irreplaceable domain of architects and designers. That creative capacity is not threatened by this technology, it is amplified by it. But only for those who develop fluency with AI tools and a genuine understanding of what the robotic construction ecosystem makes possible. When deep creative skill is combined with command of these new instruments, your value to clients and to the built environment grows exponentially. The profession is not contracting. It is expanding into territory that only those who embrace this transition will be able to occupy. So here is the question worth sitting with. Do you see AI and robotics as competitors threatening your livelihood, or as the most powerful collaborative partners your practice has ever had access to?